One of the things that is on top of everybody's mind now, next to the pandemic, is whether artificial intelligence and AI will take over my job. In this talk, let me try to cover you the current surface and then what's likely to happen. We'll cover quite a bit of subjects, so hang on with me. We all like stories, so let's start with the story. This happened when a spacecraft was going to a place where no man has gone before or no man has landed before. And the rocket was powered by computers. It was a complex system, as you can imagine. And everything was running smooth. But suddenly, the radar switch was in the wrong position for whatever reasons. And the computer was doing its own normal job that are needed to land safely. But then this radar was also sending huge amounts of data. About 15% of more data than what the computer is likely to handle at any point in time. So the computer was obviously overloaded. If this was the case, the computer is going to crash and the old spacecraft is not going to land properly. It's going to blow up and then kill everybody internally. Luckily, the designers, the engineers of this system had designed a fail-safe where the computer was able to diagnose itself periodically. And once the diagnostic program kicked in, it immediately sensed up there is 15% more load that's happening. And then it started sending an alarm with telling the astronauts that there is something wrong and trying to figure it out. And what the computer did, because the diagnostic was able to figure out that it was getting overloaded, it was starting to shut down all the low priority tasks. It was only doing the high priority tasks. So it was able to basically do prioritization. And because of that, life critical systems, life support systems where high priority systems, they were kept running. And this also gave the time to the astronauts to figure out the radar switch was at the wrong position and then configure it properly, and the whole landing happened beautifully. And if you think about this is a science fiction, it is not. This kind of happened 50 years back. This whole problem, this episode happened in the Apollo 11 moon landing. And if you can think about it, softwares were so advanced 50 years back and they are not even close to what we have today. But then let's see how in the future softwares could be very, very intelligent. What qualifies me to give this talk? So you might be wondering, why should I be listening to somebody who's going to tell about what's going to happen in the next 20 years? We don't know what's going to happen in the next year. It's just that because I've got fairly good amount of experience in the software industry. I've run my own company for about 24 years. I sold it to another large IT service vendor, and we had branches in 3 countries. And I'm also what's called as a Microsoft Regional Director, honorary title I've been holding from 1999, where I do talks on many of the Microsoft technology and strategic events. I've been through 4 industry cycles and 3 business cycles. I've learned a lot so that I can help you not to make the same mistakes. I've architected several high traffic sites. I've created a news app called SimpleJig 5 years back. The idea of this app was not to have any user controls, make it everything kind of predictive. So the system will just give you one story to read, but it will be able to predict what story you're likely to read. And the agenda for this talk, it'll go like this. We'll look at the current landscape, how things are happening. We'll also see the impact of these systems of artificial intelligence and AI today in software development. We'll see some past trends, because past is always the best way to learn what we did. History is a good way to learn at what we did before and then look at the future. And then I'll make some predictions for 2040. Software industry, like all you know, it's pretty exciting. It's been growing consistently. In the last 2 years alone, we have had like 23, 24 million software developers working worldwide. And this number is going to steadily grow. For 2024, it's going to be about 28 million, and this number is going to keep on growing. And for many of the statistics and many of the points that I'm going to be talking, I've got references at the bottom of the slide. So if you want to read more about this, you can go and read. And none of these are my speculations. There are many job roles today. If you look at many of these slides like Glassdoors and others, the top job roles that are being advertised for 2020 are some of these. For example, AR, VR engineers, virtual reality engineers are a job role that's been growing 1,400 times in the last 12 months. Another one is computer vision engineers. This is use ML to look at a image or a photograph or a stream of images coming in and studying and making inference. Those kind of computer vision engineer job roles are growing by 140%. And there is machine learning engineer, AI scientist, data engineer, data labelers, blockchain engineer, full stack engineer, so on and so forth. The last one called site reliability engineer. This is something I saw in a Google's website. Somebody who ensures that that particular property keeps on running. And the last but two, the blockchain engineer and the full stack engineer. These job roles were pretty hot a couple of years back, but they are not so hot. Even though they are growing, they are not the hottest ones. It's your AI engineers, your VR engineers, computer vision engineers. These are the job roles that are being mostly advertised about. And if you stop for a minute and think, actually none of these job roles, from your VR engineer to your site reliability engineering, existed even 5 years or 10 years before. That's how dynamic software engineering and software developer roles are. We have all seen pretty much most of your job roles. I'm sure those of you who have been in the industry for like 5 years or 10 years, you would have seen your job roles change in the last few years more faster than what they have before. Earlier, we had more of a linear job role thing. You joined in as an intern, a fresher, you became a trainee, then you became an engineer, a lead engineer, a module lead, team lead, and so on and so forth. Today, those are, I won't say have gone, but then have changed drastically. We'll see some of these job roles that we saw in the last slide. One of this I picked up from Microsoft Careers website. This is for an ML engineer in Hyderabad. This was opening that was posted a couple of months back. And if you look at it, it's pretty interesting what they are talking about. They are talking about an engineer job saying, create language models from petabyte of text data, adapt from standard machine learning methods to best exploit modern parallel environments. And these are like, I find them very interesting. These are not your boilerplate thing that we are trying to build a system which will do A and we need you to build the software code for this. This is saying you have to learn from these models and then build new ones. That's kind of interesting. The other job role, an AI engineer in Berkeley, this talks about the responsibility to be end-to-end ownership of machine learning, algorithm development around some key research areas. And the next one is quite interesting. This requires constant paper reading. At least for me, it's not common that you read a job profile, job requirement talking about people looking at scientific and engineering papers and learn it. We always thought those academia had to be separate and the industry to be separate. But with AI and ML, the constant new innovations happening in the academia is like taken over by the industry very fast. That's why you see a requirement from Microsoft saying this job role requires constant paper reading. This also requires you taking initiative to learn the newest reinforcement learning techniques. So one thing, if you read here in the job, I've just taken 2 samples here, is you'll notice these are talking about continuous learning. So it's not continuous integration, continuous deployment that we are doing now in our DevOps projects. It's about we continuously improving ourselves, learning the new things that are coming on a constant basis. It's not like we learned C++ and the next 20 years we are a C++ developer, or we learned COBOL and the next 30 years I could be an engineer in a large banking service company in the US and then I can just keep on writing programs in COBOL. No, you have to continuously learn. That's what these job roles are telling us. One of the ways, now let's look at various tools that are available to developers today that are powered by artificial intelligence and automation. For that, let's step back. If you look at what is a typical software engineering project involves, they involve pretty much 3 main categories of tasks. I will put them into these buckets. You can cut them and slice them and dice them in many, many ways. But these are, I think, largely common across most of the software development projects. The first one is business requirements or customer study. You go and talk to the customer to understand what is the requirement, what is the problem they are trying to solve, and then try to document it or trying to understand the requirement from the domain expertise. It's basically kind of a human-computer interface equivalent of you understanding from the customer the pain point or the problem and then trying to get it right so that you can design a software system. The next part is designing that software system. Once you have understood, the next one is to build the architecture, do the designing, the mapping with various platforms, tools, softwares, people required, so on and so forth. And the last one is the actual coding of typing software code, testing it, deploying it, and all that. And pretty much a lot of papers that I've seen, and in my own experience over last 25 years, and I've talked to engineers in many of these large companies, the split up looks something like this, the effort between these three workloads. And they may change plus or minus 10%, but broadly this is the indications I got from most of them, is that the first one, the business requirement, though we don't tend to think about it, the business requirement, the customer study, understanding the problem, that takes pretty much about 50% of the overall time and effort and the money spent. The next one is actually mapping, which is about 30%, the architecture, design and all that. The last one is actually 20%. The coding and the deployment is actually 20%. Of course, this varies between project. A plus minus 10 is likely to be seen in many projects. Very intense software coding projects like your kernel development or a new artificial machine learning model development, those could involve a lot more coding, but pretty much on an average, this is how the split up works out. And all these three areas today, AI and automation tools have started coming. They have come in the first, the last one on the coding, pretty much most of these tools. But as these tools mature, you will see them climbing up the ladder, and even the tools will be available for the first one. We'll try to cover some of them. The first one, this is an interesting new startup. They're called Kite for Python. What they do is they integrate with your IDE, like your Visual Studio Code. And as you start typing your code, they start giving you code snippets that you can reuse. It's like IntelliSense taken to a completely new level. It's going to look at what is the type of problem you're trying to solve. And it has also studied millions of lines of code by all the open source and the other repositories that it has access to. And from that, it is saying this is the line of code that you're likely to do now. And many of these codes, it's not only Kite, we'll see some more. Many of them are aiming to reduce up to 50% of the keystrokes that you're typing when you're typically coding. These things are just come in the market in the last few years. But one thing you have to remember with artificial intelligence and ML tools is that these tools go on improving on an exponential fashion. It's not like your last version of Windows to this version of Windows where we see incremental changes, or the last version of iOS to this version where we see just incremental changes. These tools, as people start using them more and more, they are going to exponentially grow. Something like the social media tools, the power of social media grows exponentially. Another tool, Microsoft has its own tool that they are working on called Intellicode. This also aims at a similar thing, but they are trying to currently solve the problem of sorting the IntelliSense thing. What is that is going to make sense for you currently? Is get and use more priority to what is the problem that you're trying. In this case, it's a JavaScript code that you're typing here, a Node.js code, and here it says the get and the use are likely to be more common or more likely to be used right now than the other parameters that you could be using right now. If you see, both these tools are aiming at the same problem of reducing the number of keystrokes, and both are using ML, and both are using millions and millions of lines of code that they have studied from GitHub and other projects to learn what you're likely to type now. Moving on, the next one is on the design side. There is this tool called Sketch to Code that Microsoft AI Labs have introduced a couple of years back. You should go to this URL at the bottom and try to play around. Just take a photo, just draw a design on a whiteboard. You are designing a web page or a mobile app. In this case, it's a web page. You design say a Google, you're trying to design Google. So there's a logo, there's a text box, there is a search button. You just draw that, take a photograph and upload to this AI-powered tool. It's going to recognize, it's going to use computer vision and Azure learning models to figure out what is that you're trying to solve, and then it's going to spit out the HTML. On the right hand side, what you see is the HTML that is generated. It also gives you the HTML and the CSS code that you can use. But what I like most is this tool is able to tell you what is the percentage of accuracy, or why did it a certain thing to be an image and a certain thing to be a button, a certain drawing that you have done to be a text. That's what you see in the center. So it says up to 92% or 92.65%, it says the first one that you are drawn on top of product one is an image, and 89% is the next one. Add to cart button, it's able to figure out it's about 90% accuracy. And why is it even between buttons the accuracy changes? It's very easy to guess because your handwriting is not accurate between the one button and the next one. So this is a tool that if you can just draw on a whiteboard, it's able to generate HTML. This is not perfect. It's an AI lab tool right now, but you can see where this goes. Again, remember the exponential point that I made. These tools today may not be something that you're likely to use in your next project, but these tools improve on an exponential basis. Very likely in the next few months, probably in a year, these tools from either Microsoft or somebody else would have improved so much that you can start using them on a daily basis. There's another one. Google, I think last week, a couple of weeks back, announced a new project called URL to Video. What it does, you give it an input page, you just give a URL, and the system understands the design. It kind of extracts the various designs that are there in the tool, and then it outputs a video. And Google, being an advertisement company, I suppose, their idea is that you are able to give it a web page and it's able to auto-generate animated GIFs or videos that you can then start advertising in the Google platform or YouTube and so on. But the idea is quite interesting. It doesn't just convert a page into a video. That if you take a web page and then convert to video, it's not going to make sense. But this is trying to extract the various elements in a page and then trying to rearrange them in a way that makes sense. It's a very tough problem. They haven't released this for us to play around, but their demo videos are quite interesting. You should check them out. The next one. We have seen how tools are helping you to save typing by 50%, or if not today, that's the aim with Microsoft Intellicode or your Kite for Python and many other tools. The next area is the testing performance, which we'll see where are some of these tools. GitHub, a couple of months back, announced their CodeQL, which allows you to query your repository of code as if it's a database or a data, ask it for various things. Jenkins, the popular developer productivity tools company, they use CodeQL to query their GitHub repository and then come up with hard to find bugs that they were not able to find. They had sophisticated tools to find out their bugs or their performance requirements or various of their testing things, but there were still some bugs which are very difficult to find out, and that was made easy by using CodeQL. And this is one bug that they have found out. You can actually go to Jenkins website at the bottom, and then you can figure out about 7 critical bugs they were able to find out in a recent project. This one is saying permission checks are missing in the way how a code is reading the Azure key vault. It could be pretty disastrous, but then they were able to find out using CodeQL. Another thing, there's this again startup called Functionize. It's a pretty interesting company. You give your URL or your app and it's able to figure out various bugs that are likely to happen across different browsers or different mobile platforms. In this case, it's saying what you are intended to show was big savings at the top third navigation bar, but in Firefox 58 for some problem with your CSS, it's actually showing us instant savings and not as big savings. So it could be, in this case, the difference is not big. But then in a different case where you are saying instead of buy, sell, these buttons come mixed up because of a CSS problem that's happening in one particular browser version, that could be disastrous. So Functionize, this is only one of the low-hanging fruits that Functionize can actually find out, but then this tool can actually figure out a lot more bugs by testing them across various systems. Check out this tool if you haven't done it before. Another one, this is again a new startup called Deepcode. They call themselves as Grammarly for coders. Many of us, if you're a blogger or using social media extensively, you would have used Grammarly or the Microsoft editor that's able to figure out not only spell checking, which we've used for the last 20 years, it's able to talk about grammar checking or whether your old text is very long, you should shorten them, or you're using too much abbreviation, so on. That's the kind of power that Deepcode is trying to bring it to software projects. It is saying in this case, it has given some example on this Elasticsearch project. You can go to that website and run these tests yourself. It goes to a GitHub project and then comes back and says, these are the problems. There are 3 critical bugs in your GitHub code. There are 40 warnings and it took about 10 seconds to study it. In this case, if you see, one of the problems, the last but one, is saying missing clause on java.io.file output stream. Basically, you're doing a resource leak. And these are some of the things, and these are not a rule-based system that are figuring out something which we have used in the past. These are actually using your ML to study very similar other projects to identify bugs which are in this repository, which would have been otherwise very difficult to identify. Similar project is also from Microsoft. It's called Code Defect. It also runs on very similar principles, but then it more uses your historical commits. Okay, you have committed something a couple of months back and now you are committing between these two. How likely there is a problem, that's a bug is happening. This is a Microsoft AI Lab project that again you can go and check it out. This one interesting tool, again a new startup that's being powered by ML, is that it's called Apollo QL. What it does, it's also available as a plugin in Visual Studio Code. If you see the screenshot, you will find out as you're typing a code, it's able to tell at the right hand side what is the performance, how long this particular line of code or this function in this case is going to execute. It's going to take about 281 milliseconds. It's indicative. If your system is more powerful, it's likely to take lesser time, or if more number of people are in the system, that is more resource crunch, then it's going to take more time. But then if you imagine if this similar kind of performance for every line of code or every function in your code is available, you can figure out which are the functions that are taking more resources, or which are the lines of code that's actually taking more memory or more time to think, so that you can focus on those lines rather than on optimizing unnecessary lines. This could be a real game changer as these tools mature for you to write very high performance codes. I remember many years back when we are having an high traffic website, when one of the cricket World Cups were happening, we were running on our own data centers, we were running IaaS and pretty big metal servers. And when in one of those World Cups, I think as India was winning, the traffic that's coming to the portal was really big. And this was one of the three large portals in India in those days. And a particular page was continuously taking more time than before, and we were just not able to figure out what's happening. We were just reading some data from the back end and then we are showing it, and everything seems to be optimized. We just couldn't figure out. And after logging a ticket with Microsoft and it became very priority thing, we were able to find out a particular resource in the ASP.NET code. We were not releasing it, so we were actually we were running out of threads to perform our task. So the system was waiting for a thread to be free, whereas we were not freeing threads in the backend. And it seems to be a very simple line of code that we had to read differently. If a tool like this was available, where we could see the performance impact of these things much earlier, we could have done those things really smarter. Again, these tools, whether it is Kite for Python or your Deep Code, or Microsoft's Intellicode, or the Apollo GraphQL that we saw. This reminds me a story about 25 years back when I was doing my engineering. Of course, these were the old computers, not your flat screen LED monitors. We had those CRT monitors in those days, and computers were not so common. So two of us in our labs, we have to share a computer in our computer lab, and we were learning Fortran and Pascal. And as we were two of us, so my name being in V, I was paired with a lab partner in U. So I used to call him UD. And we both were in a Pascal lab. Fortran throws your errors mostly on the runtime, whereas Pascal, as you compile, it will throw more compile time errors. And in this case, the way I write code typically is to write the outline, complete outline, where I just have the function names. I won't actually implement the functions. And once I've got the complete outline done, then I start writing individual functions. Even within a function, I'll first write the outline and then start actually punching in the actual code. But with UD next to me, as I start typing a code, I will probably not put a bracket, and he will say compile time function not found error 20. UD will immediately shout. Or as I start typing a line and I'll forget the semicolon because I'm just writing a pseudocode at that time, UD will kind of immediately scream for everybody in the lab to hear error 22, semicolon missing at the end. So it used to be very irritating. I used to shout, UD, just keep quiet, I'm writing, I'm not compiling, don't be a compiler. And because I think in one of the days of lab, we shouted, both of us, and I shouted, compiler, keep quiet. and everybody, including the professor, listened. And the next 3 years, UD was called compiler in the entire college. So that's the kind of thing sometimes you just want to not be bothered, and that's why still people use Vim and not Visual Studio Code, because they don't want distractions when they are thinking and coding. But that's, I think, is going to be very unlikely, because all of us are going to be using the tools that I showed you last, which are going to constantly, as you're typing, constantly going to try to help you. I hope it doesn't become something like Microsoft Office Clippy, where it will be a disturbance. But then this is the way these tools are going. And UD is not in this photograph, so don't look searching for it. That's the next thing. Moving on, we saw how it can AI and ML tools are today helping in coding, whether it is testing, or it is in design, or it is in the performance. That's the next phase. I also said these tools are progressing from coding to design to architecture to business requirement. Harvard Business Report released this study about a year and a half back, where they call the system as the AI canvas. If you are building an AI system that's able to take decisions, pretty much AI is most of the time decision making, right? ML is more to study at your data, find patterns, but the actual decisions takes by your AI systems. And when you are building a system like this, HBR says, try to use this blueprint or a template called AI Canvas. What they say, if you're able to fill in answers to these 7 boxes that you've got here, and then build a system like this, you are likely to succeed in your decision making. One of the examples that HBR quotes is a fire alarm system. If your job is to do a business intelligence, a business decision based on the data that you're collecting from a fire alarm system to make a decision. Consider this scenario. The fire alarm has to decide whether it should do a simple alarm and keep quiet, or should it alert to the authorities by calling 911. But if it alerts for even the smallest fire, for example, like when you're toasting a bread and it just burned out, if the fire alarm, it can alarm, but it shouldn't be calling 911. How does it distinguish between these two? There is a decision to be taken. One of the ways is to look at the past data and then make a decision. HBR suggests if you're able to use this canvas called the AI canvas, plug in this data into the 7 boxes, the system can look at the past success rate, the number of times it called 911 and it turned out to be valid, number of times it didn't call out and it turned out to be a bad thing. This kind of data, if you're able to input to the canvas, it's an example, okay, so don't worry about it on a real life scenario. But everywhere where AI has to make a decision, if you're able to build a system based on this template called AI Canvas, the system can actually take very intelligent data. Now, in these examples, we have seen in the past how AI could be used in development, in coding, reducing your keystrokes by 50%, in testing and performance, and in many other scenarios. As these systems mature, you will see more and more of these AI systems being used in business decision, and hopefully by the next 20 years, you should be able to see them in the business requirement and customer requirement mapping, so on and so forth. If you look at, like I said, past is a very good indication of what's going to happen in the future. And we all like to think that AI is very new. It came up in the last few years. It's not. Many of us know that AI tools and many of these algorithms and the mathematical models powering our ML systems today have been invented 20-25 years back. But they have been able to be consumed today by us easily because of cloud service. Many of these systems are being available to us and in a computational power which was just not available even few years before. And with just a credit card, we can buy these from a cloud provider and start using them. But if you go back a little further, a couple of centuries, AI actually came up about 800 years back. I didn't know about it, but a friend of mine called Mr. Jasprit Brindra, he wrote in a book called Tech Whisperer. If you like, you read that book about the power of digital transformation. And in that book, a chapter has been written by an AI system. In that book, he says, a Catalan poet called Ramon Lull in 1308 writes in his book called Ars Generalias Ultima, he talks about an AI system. What does he talk about? He doesn't talk about a computer, obviously, but he talks about a paper-based mechanical system that can combine current knowledge, various knowledge, and come up with a new concept. It's able to invent a new concept by aggregating various knowledge and concepts that are available. If you think about it, an AI system is that, right? It looks at multiple amounts of data, vast amounts of data, and then come up with a prediction and then makes a decision. So if you look at AI, it's about 800-year-old field. But we are not going to go that old. We'll skip in the 8th centuries and come to 2002. I wanted to look at what is the jobs that have been talked about as the high growth jobs in 2002. And US Bureau of Labor Statistics has released this data in 2002. They talked about in the next 10 years from 2000 to 2010, the number of computer and information system managers job will grow from 303,000 to about 453,000. That's about 48% growth. Likely about 50% of new jobs are going to be created in this category in the next 10 years. And we all know what happened by 2010 and what happened in the next 10 years, how the number of jobs increased exponentially in the last 20 years. And this data only talks about managers, but the same can be easily extrapolated for engineer's job. For every manager, we can easily guess there would have been 5 to 10 jobs created. And that's how fast in the last 20 years the jobs in the computer industry and the programming industry has grown. If that's the indication, the next 20 years is going to be phenomenal. While I was researching for this topic, I also found out in a Medium article, which I have referenced at the bottom, that this article talks about developers are already living in the future. And if you look about this article written in 2015 and read it in 2020, many of these things have come out true. Today, most of the projects, in fact, 98% of projects are using open source. And we're all collaborating openly in Slack, Medium, and Teams and all that. We are using these tools to be very collaborative. And all of us are working. The pandemic has made us remote work. Almost none of us are going to our offices. And robots have taken over our job. That's like a stretch, but then let me explain what I'm trying to say here. Today, how much of us are doing manual jobs? Earlier, 20 years before, I remember to deploy a web code, you have to log into you have to FTP to a server, put the code, then do a build and then deploy and all that. Today, though we are doing those tasks, we have automated that to a very large extent. We are having scripts which are able to automate it, or we are using powerful systems like GitHub Actions, and we are able to do the CI/CD integration very well. We are able to build it, we are able to test it, we are able to deploy it, and then we are able to collect feedback telemetry, and then if there is a bug, roll back the build that we put in. All this we are able to do. So if you look at those scripts or those actions to be robots or robotic actions or automations, then robots have taken over a pretty good size of job that we were doing 20 years before. In all this, if you look at it, imagination is the key. Today, it's not that we are inventing new things. It's not that we are starting from a computer or building a computer, building a data center network. No, we are using cloud. But what is the power that as individual software engineer we are bringing to a table today? We are able to bring our imagination. We are able to bring our curiosity. We are able to bring our knowledge that these projects exist. This is our understanding of the customer problems, and this is the way we can map these two and solve a particular problem. So it's the combination, again going back to the Catalan poet Roman Lull, 800 years before, when he talked about combining existing knowledge to create new concepts. That's pretty much what we are doing today in software projects. We are combining various open source projects, we are combining various tools, and we are able to create something new specifically for the current customer problem we are solving. So in that sense, we developers are already living in the future, and that's an indication that we got from 5 years back, which we can validate. One of the things I was thinking for me to predict the future is to look at other fields that are not related, but we can be thinking them have grown phenomenally in the last 100 years. One such profession is medical profession. 100 years before, when a similar pandemic came in 1918, the Spanish flu, we know that there was a pathogen that was infecting humans, but we didn't know what was the pathogen. Today, we know by weeks or just in months after the infection came in China, we were able to study the virus and say, this is the virus, it has the structure and all that. It's so minute that human eye can't see, even a microscope can't see, but we are able to use powerful tools like electronic microscopes to look at that and come up with the structure of the virus, the RNA, and able to come up with the test for it and all that in just a matter of weeks. Think about it, it's phenomenal. In 100 years, our knowledge about of our information about our biology, about infection, about pathogens have come. We haven't come so far to invent a cure quickly, but then in the next 100 years, possibly we'll be doing that. And right now we have vaccines, and maybe vaccines are just months away. And that's the speed in which medical profession has grown in the last 100 years. Look at the diagnostic, look at the surgeries that we are able to do, organ transplants, which would have been unimaginable 100 years back. And that's how the profession has grown in the last 100 years. And it's also very easy to guess that at this pace, medical profession is going to look extremely different, extremely mature, extremely powerful in the next 100 years. And if that is an example, that's an inspiration for computer engineers, sky is the limit for us in the next 100 years. But also at the same time, also look at what has happened in the last 100 years. How has the industry also matured, the medical profession industry? It's an highly regulated industry. Everything from the drug to deployment to vaccines to therapy is regulated. There are regulatory bodies. In India, we have ICMR regulating or studying, researching on many of these things that can be given to a patient. That's how regulated the industry has been. Remember this concept again. There are many regulatory bodies looking at this, and maybe that's a way that software industry will also go. Just park this thought. Or you can compare it with the civil engineering. The buildings that we are able to construct today, like Burj Khalifa, which is hundreds of floors high in a desert where the sand is loose and it's not a very stable ground, and it's extremely windy. Deserts are windy, and we are able to build the world's tallest skyscrapers in that place. That's how far civil engineering has come in the last 100 years. And if this trend continues, maybe in the next 100 years, we'll have gravity-defying buildings which will just float, like in science fiction movies, like in Jetsons that I've got behind me. Those are possible, and that should be the inspiration for the software engineering field. Pick up either between doctors or civil engineers and draw your inspiration. Let's look at some of the larger trends before we make predictions for how it will affect our software development in the next 20 years. By 2040, these are some of the large, big trends that I see happening. Before we do that, this is a very powerful quote by Bill Gates that I always like to look at when I want to draw inspiration about looking or predicting what's going to happen in the next few years or the next many years. He says we always overestimate what's likely to happen in the next 2 years, but we underestimate what's possible in a decade. It could be, we all think, oh, the next version of iOS or Android is going to have so many features, it's going to have AR, it's going to be transparent, so on and so forth, but we get disappointed when it doesn't happen. But look at what has happened in the last 10 years. Though I was able to see by 2003 that smartphones will be the first and only computers the developing world will use, nobody saw the power of smartphones or the innovations that will come in smartphones. Today, a smartphone that we have is kind of unrecognizable by what we had like 14, 15 years before. And that's the pace in which things are going to happen in the next 20 years. So remember that technology advances in leaps over a decade, but it goes evolutionary, it goes incrementally in the next few years. Remember that as we go through the next few slides. By 2040, if you were to ask anybody in the industry what's going to be the most impactful invention that's going to happen or technology that's going to happen in the next 20 years, the top of the mind, the top of the recall, they will say is quantum computers. And quantum computers is already here. Many of the large IT giants have already proven that quantum computers work, but they are trying to make it more available, more easily available. But in the next 20 years, they are going to be easily available. It's going to be available as cloud services. Quantum computers even now require large area. They are extremely heavy. They are climate controlled. They are unstable. So cloud providers like your Google, Microsoft and IBM's, they will be providing cloud computing as a service, QCAS, just like we have today cloud software as a service, platform as a service, infrastructure as a service. Cloud computing will also be available as a service by 2040. 95% of the organizations will be using them as a service, and the next 5% are likely to be your IT computing giants. And one of the study by Gartner says even by 2023, 20% of organizations will start budgeting for quantum computing projects. In the next few years, they are likely to be experimental projects, but then by 2040, they are likely, or even I can be sure, There'll be production projects. And what is the impact that quantum computing will have? Remember, quantum computers are not going to replace our silicon computers. These are going to coexist because silicon computers solve a very different problem. Quantum computers exceed or excel only in mathematical problems or mathematical predictions. Your AML is going to be phenomenally enhanced by quantum computers. Communication is an area where quantum is going to make phenomenal leap. If you think 5G is revolutionary, 5G, the technologies following 5G after quantum computing is going to be something we just can't imagine. They are going to be so powerful. And another thing is, one of the side effects of quantum computers are current encryptions are going to be no more valid. So we have to be coming up with encryptions that are valid even on a quantum computer. So that's by itself a very exciting field. If you're interested, just study many of the papers on even some of the keys that are valid even in a quantum computing era. But those quantum computer is for real. And even today, if you can go to any of these cloud providers, for example, Microsoft has a simulation environment where you can start doing projects that will, once quantum computing is readily available, you'll be able to deploy on that and see the results and all that. On the right hand side, you see is a real quantum computer running in a Microsoft data center. It's large. It's climate controlled and it's very expensive. That URL talks to you much more detail about this. So quantum computers started appearing and they'll be mainstream by 2040. This is a very important thing. I like to place it here, though it's not technology per se, but then it's going to have a far impact on each one of us and how we are building software. Because in 3 years before, Chinese government said by 2030, they want to be the leader in artificial intelligence, and they are on track. If you look at this research paper finding, they said about top 50% of all AI papers, the amount of citations by Chinese universities and the Chinese researchers are growing phenomenally. Look at, by 2020, they are actually intersecting with the US and then they are going to take off. And if you see the citations, look at the lakhs and lakhs of citations happening by the top 10 Chinese universities. And this number is just going to keep on increasing. And again, remember, one of the advantages China has got, because of their rule, they have huge amounts of data. And because of their population, which nobody else or in the US doesn't have access to that kind of data, China is having lots and lots of data. So they are able to build these AI models a lot more powerful, and they are investing lots and lots of public money and private money on improving AI algorithms. So by 2040, I can imagine many of the tools that we are using in software engineering for AI/ML will be from China. If you ask me about India, Indian government has been doing something on that. There is a paper comparing about 40 countries across the world on their AI strategies. India does figure there. But then in the next few years, I think we have lots of ground to catch. Hopefully Atmanirbhar also start spending in AI/ML. For that, we have to also do a lot of changes and a lot of improvements in the way we study, and we also have to have our brightest of our kids staying in the country to do these research. But that's a separate topic. But one thing for sure, by 2040, the impact of China in AI/ML is going to be phenomenal. We'll be using many tools from China in our development chain and even in deployment. The next thing, regulation is going to happen. That's why I said, if you remember my doctor slide, when I said you should look at what happened in the doctor profession 100 years to draw inspiration for the next 100 years. Today, medical profession is an highly regulated industry. There are regulatory bodies. So should that be the way technology go? Probably yes. Not every project requires a regulatory body to be overseen. But then I think where as systems like AI are in life critical things, and like the spacecraft I was talking about, where life and death decisions were made by computers, you definitely need a regulatory body to look at your system. You require, when you are building systems for life support systems, there has to be a regulatory body on your code. There has to be audit on your code to study how is your AI taking these decisions, what is the model that it's using. So that's likely going to happen. And there are indications we are already seeing, right? Today, all the big four, your Google and your Facebook, Amazon, Twitter were called by US congressional for hearing. Similar things happen in Europe and many other parts of the world, where these big technology companies are answerable now to lawmakers and how they are building their solutions. It's not directly about our technology, but it's about technology company, because as they get regulated, the technology that they create and which we are consuming will also change. Today, if you think about it, the vaccine for COVID has been invented or has been created 6-7 months back, but we still are not able to get it. It's not because it's not invented, it has to be tested. There are regulatory bodies. You just can't give a vaccine to somebody just because you invented it. You need to go through a regulatory testing process. And those kind of things are likely to happen in AI systems that we are developing in the future for life support and life critical systems. So we have already seen indications for it with there is a recent MIT technology review paper that says you just don't need to break these big technology companies. You can also regulate them in many other ways. 4 ways they suggest is to force big tech companies to share their data with smaller ones, and don't let tech platforms favor their own solutions over third parties, which we have seen. European Union is investigating Google, whether their maps, whether their video, YouTube solutions is favoring their solution over third party equivalents. You can also stop technology companies from locking in user data. Data should be portable. You should be able to take your data to any service you want. Lastly, prevent technology companies from combining data. Just because there are AI and big data solutions, don't combine large data to infer more and more about users. So these are ways in which we have already seen regulatory and lawmaking bodies look at how to regulate big technology, which will have a direct impact on the technology that comes out of these companies. Switching gears on the tools, as more and more requirement software is eating the world, we'll have more requirements for software, but we don't have those many software engineers coming. We can't be creating them in that speed. And also it's becoming more and more complex, which means it's more and more expensive, which means the low-code environments are becoming more attractive to companies. Low-code, I mean Microsoft Power Apps or Zogo Create or Orangecake Kifslows. These tools allow even a semi-trained software aware person to develop software. So these tools are going to become more and more powerful, and companies are going to be using more of them. A recent study by Forrester said there is about $6.7 billion going to be spent on low-code solutions this year, which is about 8% growth from the last year, and it's going to grow 15% the next year, 2021. And with the pandemic, I suppose this number is going to increase. If 15% is going to be the growth 1 year, imagine the percentage of growth that's going to happen in the next 20 years with these systems. And as AI systems mature, these low-code systems will tend to be becoming more and more of no-code system. And that's going to become more and more powerful. Today, we think Power Apps to be some satellite solutions, peripheral solutions that people build, business people build, and not developers. But remember, these systems are going to become more and more powerful, and people will start solving more and more complex solutions with these tools. And what does all this mean? In the last 30 minutes, we saw what can happen, what are the trends, what's going to happen for developers, how by 2040, these things, whatever we saw, are going to impact development. One of the report, if you go to this site, will robots take my job? It's a very interesting site. If you go there, other day I was playing around with few job titles there. One of the job roles, say a neurosurgeon, it says is a job that they have to be worried because they will be replaced by automation. If you think about it, it's easy to understand why. Because a neurosurgeon becomes better and better by his experience. More operation he does, he becomes better. But an AI automation system can study from millions and millions of surgeries done across the world and learn what works, what doesn't work a lot better than a surgeon. Still, a surgeon is not going to be replaced, but then he's going to be augmented by these tools, and these tools will become so sophisticated, so knowledgeable in the next many years. But for us as a computer programmer, it says you have to start worrying. It's going to have a minus 8% growth. There's a 48% probability your job will be replaced by automation. And again, take it with a pinch of salt, because the same site, will robots take my job, also says computer application developer's job has nothing to worry, it's going to grow. And there is a distinction they make between these two. The former computer programmer is more systems, platform development, whereas the later is more business problems that you are solving. And they don't distinguish computer developers and who code and who use low code environment. I suppose most of the growth that they expect happening in the later job roles are going to be low code environments. But then it's good to start worrying. As Andy Grove, the former CEO of Intel, says, only the paranoid survive. It's all loss or gain with all this AI and automation coming in. What will happen? Recent Forrester study says that there is going to be about 16% of US job lost in the next 10 years because of automation and AI. And if that means about 20 million jobs will get lost, and only about 13 million jobs will be new jobs will be created because of these tools. And again, take it with a pinch of salt, because many of the job roles that will come in the future, we just have no idea today. Just like the job roles that we have today in 2020 that didn't exist 5 years before and couldn't be recognized 10 years before by anybody living in 2000 or 2010. Job roles in 2040 are going to be extremely difficult to predict. There's going to be new opportunities, but existing jobs are definitely going to go away, good number of them. There is a report by McKinsey classifies between gender the job roles that are going to go away or at risk because of automation in the next 10 years. For men, they say, and it's very scary, look at the number for China, 66% of the jobs done by men in China are at the risk of being taken over by automation in the next 10 years. And if you can imagine, for 20 years, this number is going to go much more worse. For India, it's about 44% of job done by men are at the risk. They are not saying it will go away. They are at the risk of being replaced by automation. Generally, women are more disadvantaged when it comes to job. And this number could be scary for women. But fortunately, McKinsey report suggests that only 12% of jobs that women are doing today are at the risk of being replaced by automation in the next 10 years. And they also put a caveat that it could also mean that a lot of the jobs women are doing today are at the lower value chain or low cost jobs that companies may be hesitant to invest on upfront high cost on the automation required, and they might just retain it for humans to be doing the job. So that's why women may not be impacted as much as men. 44% of men's job in India are going to be impacted by automation, whereas only 12%. So that could be a silver lining, or it could be because of the category of job roles involved. But that's the kind of projection McKinsey makes. What are the scary parts? We have seen a lot of things now. What are the impact when it comes to job for us? One thing, as I keep saying even earlier, none of the job roles that will be there in 2040 will be even recognizable for us today in 2020. There are going to be completely new job roles that are going to be created. Whether the net result is going to be positive or negative, we'll have to see. But definitely the job roles in 2040 are going to be very, very different than what they are in 2020. One of the backbones of IT industry, IT service industry in India is our time and material way of billing. But that's going to go away, because as more and more of these systems becoming complex, expensive and dependent, customers are going to say, why should I pay you for the time? Because you are going to be using more and more of AI tools. And more, say if these tools are going to reduce 50% of your keystrokes, why am I going to pay you for the time? I'm more going to paying for the business value that you're creating, or for the outcome that comes out of the contracts that we are doing between us. So customers are going to move to those kind of models, and time and materials are going to, or would have long gone by 2040. This also means baseline maintenance will be history. Why many of these software systems that we develop will be maintained by automation tools or AI tools. We already saw how these tools are able to find the bugs. Even today, we are able to, as a bug happens in a system with our containers and Kubernetes systems, we have tools that can figure out there is a problem happening, and it's able to spawn out new instances or new containers and reroute the traffic. These are basic things that we are able to do even today with DevOps and containers. So when those things are happening today, it's very easy to imagine in 2040 that companies are not going to be paying you, or customers are not going to be paying you just to ensure my software runs in the baseline. Only for new enhancements and new features, customers are going to be paying, which also means junior software engineering roles who are into maintenance today are not going to be with a job role by 2040. And we can also imagine, as I said, low code becomes more of no code. You will have seen more and more of business managers or business users themselves creating their solutions. So when companies think about creating a solution or software, they are going to by default choose no code first. And if a problem is too complex for no code, only then they are going to go into coding. So these are going to be having a lot of impact on the way we recruit, way we train engineers, way we recruit, way we promote them, way we create job roles. So all this is going to be interconnected. Infrastructure jobs are going to be gone. Even today, lesser and lesser of data centers are being created. All of our solutions are going to go into cloud. By 2040, most of the solutions will be running in cloud, which also means we don't need to maintain these infrastructures. Cloud company will maintain. You could argue cloud companies are recruiting more of those engineers, but we talked about earlier, right? Automation and AI are going to build these tools which can self-monitor, self-heal these systems. So the need for engineers to maintain infrastructure is going to keep on coming down. Software performance, quality, testing roles would have long gone. We have already seen tools like your Deep Code and Microsoft Intellicode and Code Defect and all that, which are at their infancy now. But then in the next 20 years, they are going to be so mature that all these tasks related to performance, testing, debugging, deployment are all going to be done by automated tools. There are not going to be any engineering roles for any of them. This also will have the impact on how we are doing DevOps, how we are doing DevSecOps, what is our pipeline, CI/CD. All this will go tremendous changes in the next 20 years because of the maturity of these tools. One other thing is going to happen in the next 20 years is the premium commanded by AI/ML engineers are going to go away because more of these tools would have matured and they will be more like commodity. And you will be available a lot. Every engineer will be an AI/ML engineer if you think about that word on a very loose sense. But then the premium will be for new technologies like in quantum, which we can hardly imagine today. They will be commanding the premium. There are also good things to this. More and more of software will be created, whether it is coding. What is software development? Is it coding? Is it creating softwares? If you think of the larger definition, more and more of softwares are going to be created. More and more people are going to be creating software. More and more job roles are going to be involved with software development, or as part of their job, they are going to be doing software development, but they are going to be using no code environment rather than an IDE. So that's a huge opportunity. Quantum computing, quantum communication, like I said earlier, is going to bring in a completely new scope, new opportunities. That's going to result in new job roles. And this thing, if you search for this lattice career progression, it's a very interesting concept that people are talking about now. The linear job growth that as I join in an IT service company or an IT company, software company, I'll be a fresher, a trainee, an engineer, a lead engineer, module lead, team lead, project lead, so on and so forth. Those linear progressions are going to go away. I'm going to be doing lattice career progression, which means in some years I'll grow horizontal, some years I'll grow vertical, some years I'll go zigzag. I will be switching industries, I'll be switching departments, I'll be switching skill sets, I'll be switching the specialty that I work. But as long as I'm able to do continuous learning, continuous improvement, just like CI/CD on myself, I will be growing in the organization. But those growth are going to be more in a lattice format than in a linear format. Be prepared. Don't think that I have been in this company for 10 years, I should be a lead, I should be a manager. Those kind of linear growth are going to go away. And in all this, creative self-starters, people who are curious, who are continuously learning, are going to do well. If you are sticking that I'm a COBOL developer, I joined as a COBOL developer 20 years back, the next 20 years I'll work as a COBOL developer, those days are all gone. You have to change your skill set, you have to change your platform, you have to change your department, industry, everything. That's, if you are those curious, self-improving, then you can grow. Otherwise, you will have a tough time. How to stay relevant? We have seen a lot of things. What's going to happen? How am I going to be relevant in this sea change that's going to happen in the next 20 years? First and foremost, leave the baggage. Don't think that I used Node.js the last 5 years, I'll be a Node.js developer forever. That's gone. You have to be adapting not only the tool set, the platforms, the way we develop everything. You should be ready for new things. You should be continuously learning. And one good thing with the internet and the remote work and all these remote learning platforms like your Udemy, edX and all that, there is phenomenal amount of growth. There is this site called Masterclass where some of the best minds in the world teach you on whether from cooking to music, you can learn from the best in the world. Be ready for all those continuous learning things. Computers are not going to be buying from computers. Remember that. People are going to be buying from people. Human relationship is going to be more important than ever. So your interpersonal skills, communication, globalization. We are living in a globalized world. So more and more collaborations are going to happen, which means you should be able to collaborate with more. Just because you have a Slack or a team site doesn't make you collaborate. At the end, your culture is important. So those things have to be extremely important than ever before. Lastly, be curious and be informed. Don't learn only what is happening in your industry. Like the China example I was talking about. Be aware on what's happening around the world, what's happening between China and the US, what's happening between India and China, India and US. Be aware, because all this is going to be having an impact. And as regulations come in, you have to be more aware of these things. There may be regulations that will prevent you from working on an abroad project because of the regulatory requirements. So that will mean your opportunity going abroad might also get reduced or might get increased. So all this are open. So be curious and be informed. Lastly, kind of summarizing all the surface we saw now. These are like 6 points that I like to leave you thinking. China will be leading in AI/ML. Many of the tools that we'll use in 2040 might be coming from China. Be open for that. If you want to learn Chinese, be doing that also. I also hope India and Atmanirbhar succeeds and we also be a force to reckon with in AI/ML. But the current trajectory is all for China to be leading in AI and ML. There will be registrations. You might need to certify to be an engineer working on mission critical systems. There will be audits of your AI code and AI models and all that. Be open for that. Hardware will disappear. It will be more and more in the cloud. Software will become so complex. You can't look at the source code of a software and trying to figure out what it does because it's so complex that you'll need AI enhanced tools to look at the code or look at the system that's developed and figure out what it's trying to do. More and more of these development will happen only with AI tools and not without them. And every job will be a software engineering job, so be open. No code environments will be the de facto, like I said, so you have to work with people, business managers more and more, and you have to integrate with those tools. So don't resist those changes. Always be creative so you will do well. Lastly, I'll leave you with this slide. Anything AI or automation is not to replace humans, it's to complement them. And the inventor of Doug Engelbart puts it very nicely, the mouse inventor. He says technology should not aim to replace the humans, rather amplify human capabilities. It's a very profound statement. And lastly, if you haven't seen his demo of introducing computer mouse on a GUI about 50 years back, go to YouTube. It's called Mother of All Demos, and Doug Engelbart is phenomenal on that demo. So I'll leave you with all that. Let's continue this conversation. If the chat window is open, let's continue the conversation there, or you can chat with me on my Twitter at Venkatarangan or at my blog. Have a phenomenal conference. Stay safe, stay healthy. Thank you.